So I'm the BP professor in an institute called the BP Institute, which is part of the University of Cambridge. And it's a fluid mechanics institute where we look at a whole series of problems in multi-phase flow and also single-phase flow. A lot of the problems we work on are related to energy and the environment. And this book actually summarises quite a lot of the research we've been doing for the last 10 years, looking at problems of flow through porous rocks or pumpable rocks on the subsurface. And what's interesting is the interaction between the earth sciences and the geological structure of rocks, and understanding how that then impacts the way fluids move through the rocks. And then we also got very close links into industry, particularly the energy industry, where there's challenges about how you actually can drive the fluids through the rock and recover some of the fluids, or in the case of carbon sequestration, how you can actually put fluids or pump fluids into the formation. Yeah, so I have a series of projects looking at different aspects of flow through porous rocks as one part of my research program, and we both carry out a lot of experiments in the lab looking at small-scale models of rocks where we use analog systems which we may use glass ballatini, little glass beads, and make little bead packs, and then we have a look at the large-scale flow structures that develop through these bead packs as analogues of how flows move through rocks. And we also develop mathematical models to try and quantify and describe those flows. They're models of the small-scale experiments, but by understanding the physical balances and getting what we call the dimensionless groups, you can then apply those models at field scale and try and understand some of the dominant controls on the flows. There's a series of very interesting experiments you can actually run to look at how reactions can then feed back on the flow, because if you react a fraction of the porous medium, you change the structure of the porous matrix, and you essentially make high permeability pathways or channels through the system if you dissolve some of the minerals, and that can then act as a focus for fluid flow that you subsequently put through the formation. And so there's some very interesting effects, and if the fluid you inject has a different density from the fluid in the formation, that can lead to reactions that are controlled by buoyancy forces. So you can get very interesting patterns of reaction.